Welcome to our webinar today on energizing our future and using drones to teach energy education. I'm Gabby Temple, the project manager for the Create National Energy Center, and just a little bit of business. So if you have any questions during today's webinar, please put them in the chat. There will be time at the end for Q&A. And I ask that you please turn off your microphones and videos to reduce any feedback. I'm sorry, I now have a weird. Oh, of course it's. All right, now maybe I can advance my slides. There we go. So the Create Center is funded by the National Science Foundation Advanced Technological Education Division. And in a nutshell, we provide faculty resources and professional development opportunities for educators in the energy sector. These can be found on our website at createenergy.org. So we have a few upcoming events. We have 4 workshops, one of which coming up in April is a virtual workshop. And on April 15th, we have a faculty coffee hour on recruitment. You can find these events on our website under the events tab. So today, this is the first of our innovation series webinars. This series will continue the next Fridays and the following Fridays in April and end on Wednesday, May 8th. If you are interested in attending any of these webinars, you can email me. And now let me tell you a little bit about today's presenter. So Denise Renfro is the director of the Academy of Green Technology at Douglas Byrd High School in Fayetteville, North Carolina. The Academy of Green Technology is a 4-year career and technical education academy that focuses on preparing students for careers in renewable energy generation with a focus on solar energy. Denise has degrees in physical education and physical sciences from Indiana University, and she has been teaching for over 30 years. She recently received the Presidential Innovation Award for Environmental Education from the EPA for her efforts to provide STEM opportunities for her students, specifically as it relates to the environment, and she received the Governor's Discovery Award to help fund professional development for her choosing. She also serves as the chairman of the Board for Sustainable Sandhills, a nonprofit dedicated to supporting and enhancing the communities and environment of the 8-county region of the Sandhills through education, demonstration, and collaboration. And with that, I turn this over to Denise. All right.
Thank you, and let me share my screen here. I can find the right screen. Let me get the right, here we go. And so we see full screen.
There you go. Okay. You got it.
All right. Okay. Yeah, let's get to the right slide though. All right, so the topic today is teaching energy with drones. The pictures here in this first set of slides are just some of the ways that we're doing this now. We've just recently started teaching how Scanifly sites solar panels on roofs, and our kids are now taking courses with Scanifly. More details with that later. The bottom right is from last week. We were at a STEM day for a local elementary school. We were teaching kids how to fly these little tiny drones that you see. It's hard to see with the black shirt there, but we almost always discuss this with respect to energy. Again, we'll go into more detail later. The bottom right is using a thermal camera on a drone to inspect a substation, an electrical substation, and the top right happens to be at a Create workshop this past summer at Andy McMahon's place at Carolina Community College. You can see our little fake utility poles, and if I accidentally call them telephone poles, I'm giving away my age, but we build these little fake utility poles, and then we fly these drones. We program them to fly around them as we learn a little bit about energy. Sometimes it's engagement, and sometimes it's about workforce education, and we'll discuss both those things as we go along. There are a million uses for drones in the energy industry. These pictures, again, just represent a handful. Recently, again, with a group called Energy Literacy Fellows here in North Carolina, we were at the Southport nuclear facility in that area there, and they talked about how they use underwater drones to check out their intake and outtake pipelines into the ocean, right? So that's just another way that energy is using drones, not the flying kind, the underwater kind, but the drone's a drone, really. Inspecting wind turbines, hydropower stations. Here's another nuclear. We're looking at the cooling tower. I like this, the middle one here with all the trees. This is using, I think, LiDAR technology on a drone to see how far away the vegetation is from the power lines here. And then last, I think this is actually another wind turbine inspection, but it could be a site assessment. Either way, these are just the many ways that we're using drones in the energy industry already. And if we're in the workforce development for energy, it seems like drones is a no-brainer way to get folks engaged and to actually give them a career. Let's see. I thought it might be important to give context, although this has already been alluded to in the introduction, but I teach an academy at a high school. It's 4 years. Students come in and they give us 1 to 2 classes of their electives each year and follow a path through our program. We study the environment. We study, well, drones these days. We study renewable energy of all sorts, but the ultimate goal is they end up at the community college and they're involved in solar installation of some sort. We've had kids go on and be solar installers. We've had some go on and be electrical engineers. We have some in power generation in the military, and we have some in drones. So they do all sorts of things. Critical to us, though, is that they're still related to, the green industry, the energy industry, which I think is super important. So this kind of gives you some context for where I'm coming from. And I think that it matters probably to some of us anyway. It's one thing to have this big program and say, okay, let's go fly drones. It's another to just teach a unit on energy in your classroom, and imagine buying a bunch of drones for that might be different. I will talk about those things today because both can be had. You can do one or the other, I think, in a reasonably financially sound sort of way. And again, we'll get into that in detail as we go along. So now that you have a little context for where I'm coming from with respect to drones and energy, I want to talk about the context of where we're at today. Energy is undeniably at the core of the global and local challenges we're facing now. Due to our emissions and climate change, and those challenges, they require thinking very differently about how we are going to provide energy and how we are going to interact with our environment. For America, at least, changing that is a real cultural shift. I have up here, it's a monumental cultural shift. We are a highly resource extractive, profit-driven economy. And right now, we try and control our environment, but to learn to live with it so that we can change and deal with some of the impacts that are coming from climate change is not going to be easy. Science has already given us the way we need to solve this problem. And the fact that we're not solving it right now, science is also trying to provide us with technologies. But it is going to require the actual change. Science has given us the answer and we haven't done it yet. It's going to require a cultural shift. A cultural shift. And that cultural shift requires a long-term outlook. And I am totally biased, but there is no one better situated to leverage a shift in thinking about energy and the environment than educators. I mean, I love this picture. Look at these kids just involved with putting together this little wind turbine. They are as happy as can be. We see up to 1,200 kids in this one activity every year. So we as educators are in the perfect spot to change the mindset about energy while we're also helping develop voters, smart voters when it comes to energy, and our workforce, our future workforce. So our society's future depends on nurturing the next generation's understanding of the energy industry. And this right here, these young people represent that next generation. Those are my students, and no, they're not all 12 foot tall. There's just some strange teacher laying on the ground taking a picture up with the Amazon wind turbine behind them. We are at the Amazon wind farm here, hearing from the folks there on how they use wind turbines, how much energy they produce, and how they deal with the local economies when they do this. So it's interesting, and our kids need to know this. And if we prepare this generation right, I would say that makes us the most important people on the whole planet as educators. I'm guessing many of us here are educators, so you'll have no argument with me on that, I suspect. All right. Oops, why am I going backwards? There we go. Yeah, the world becomes what we teach. This is why we're, I think, the most important people on the planet during our current challenges. We waste no time in the Academy of Green Technology. We get them young and we start teaching them about energy about as quickly as we can. This little girl's being helped by a football player on this side and a baseball player on that side, who's also in the Academy of Green Technology, and they're helping her build this little solar car, same one this young man's holding here. He's a 5th grader at another local elementary school. And I didn't mention before, but our students in the academy, they're with us 4 years. They're taking all these classes, but they also have to give 50 hours of community service every year. And we leverage those community service hours to engage students in energy, and in particular in drones. And we'll see that here in just a second. Yeah, so bring on the cultural shift, right? Because we're all going to be, as teachers, we're all going to be prepared. And so innovating and educating and engaging these students in energy, we chose our main route to be drones. Back in 2013, we were just our academy was just 3 years old. Our state, North Carolina here, was the #2 solar installer in the nation behind California. And in 2013, I heard about drones being used to inspect wind turbines. Well, we taught a little bit about wind turbines. So I'm like, told our administration, like, hey, we need to do this. And next thing I know, not expecting much of anything, they're approaching me and saying, let's bring on drones. And we've not looked back since then. We've chosen drones as a means to engage students, and we do it everywhere, all the time, as much as we can. And we feel like it's super successful. And given we are a workforce that's energy related, we also feel like we can do the workforce and we can engage kids at the same time, and both benefit each other. This young man, this is the workforce. He's preparing to be a workforce. He wants to be a drone pilot. That is his goal. He's a junior right now, with his Part 107 license, so he can legally fly commercially a drone. This young man right here is already at NC State. He wants to be a paleontologist, but guess what? He wants to study early atmospheres to look at climate change, and he also wants to start using drones in paleontology. Not sure how he's going to do it, but hopefully he is. But right here, he's just engaging with getting another student to engage in drones and energy at a career day in our county. And the third picture, well, that might not be the best picture. We best be careful. These are my pilots right here. And look what they've done. They've zipped all of their PPE together. So I'm not sure if that bodes well for drones in the energy industry or not, if these students are in charge, but they actually do quite well. You can see the drone behind them there. And this was our largest class at one time of drone pilots. So we had 5 at once. The classes tend to get small by the time we get this far along in our program, but now we're up to 15 or 20 drone pilots in just a couple years. All right, so we chose drones, and this is our engagement piece, right? So we use this little drone. It's called a Tello drone. Now, I believe folks at the Create workshop use these Tello drones. DJI has done this drone, but they've now decided to discontinue selling it it'll still be useful probably for a good 3-4 years. There are outside organizations that support it, but it is a fabulous drone. We will keep using it for engagement. And it turns out that the science company Pittsco has a new drone that's almost identical. It's actually cheaper, and it can be used in a similar way. I will have all of this stuff available, all this information available to anyone who wants it later in terms of identifying different drones and things you might use. For now, though, I want to tell you how we use these when we engage students. Down here in this lower picture, this young lady in the back is my student. We were at a STEM day again, but kids love flying drones. And just again, I love this picture. It's 3 girls, which is unusual. Even in my program, I only have a handful of girls so far, but it's 3 girls flying a drone, having a blast at a STEM day again. Usually the drones are one single station out of multiple stations. Those other stations are solar and wind turbines. And at other times, if they're at our school, we'll actually have a wave energy station. So we talk about drones and we always bring it back to the energy, and they go from one energy station to the next energy station to the next energy station. So it's easy to sort of combine them all together. A little harder if all you're doing is drones, but it can be done. And this next picture again is an example of how we do that. This again is at a Create Energy workshop. And this is just PVC pipe with solar cells from veneer. And we just Velcro those solar cells on. And then we give a drone, we give a tele drone with the remote or sometimes with your phone. That's kind of nice that you can do it both ways with this little drone. And we use a thing called drone blocks. So if you don't know drone blocks, it's block coding. It's much like Scratch, I think. And it allows you to fly a drone. And now, just most recently with drone blocks, you can tell the drone when to take a picture as well, which is going to make this event here with the solar farm, so to speak, even more relevant and easy to use in terms of teaching. You code the drone to fly back and forth in whichever way you want to, but to fly this solar farm and inspect these solar cells. And now you can tell drone blocks when to take a picture. So we've taken construction paper and we just put like little yellow squares on 1 or 2 or 3 of these solar cells, and they have to fly in a pattern and they have to take a picture of each drone, and then they have to identify, which is not hard, but they have to identify which panels are not working properly, right? And to boot, now this drone here has a little camera in front, doesn't do well at taking downward facing pictures. That used to make this a little more challenging, but now you can 3D print a little device to go on the front of your drone, and it will take downward. It will allow you just put a little mirror on it and it'll allow it to take a downward facing picture of what's below you, right? So again, this is just engagement. We're just trying to get kids to engage with energy. We want these kids to understand energy, to grow up. We hope we see them on our academy, but we want them to be good voters, right? We want them to respect the environment, to vote for the environment. And young people seem to be heading in that direction. We're just trying to inch them along that way any way we can. And there's nothing more important to our environment than energy. So, and that's where we happen to be. So we're just pushing that along. All right. So from engagement, and I guess we could talk about other ways that we engage. You saw the flying the utility poles earlier. We're working right now on building trying to figure out what we need to build like a 6-foot tall fake wind turbine so that we can practice how you would code a drone to fly and inspect it. We talked to the folks at Amazon East and they gave us the name of the company that flies their wind turbines. So we're going to talk to them and we're going to practice it in class. We have a wave tank. We're going to put offshore wind turbines in our little wave tank and wire them together. That's more practice with the energy industry, right? And then we're going to fly a drone to go out and inspect over our little wave tank out in the ocean, so to speak, right? Just a way to engage kids, right? It makes learning fun. And when learning's fun, you remember things, and gee, you might even go into the energy industry later. All right, so workforce education is a whole different ball game than engagement. First of all, you have to have a drone pilot's license, and you might consider that too, even as an educator. If you're going to do this, you have to get yours first before you can have students get theirs, right? There's an FAA trust license. This is a recreational license. In North Carolina, if you are teaching even the tiny little Tello drones in your classroom, you must get a trust license, right? So it's a recreational license. The FAA wants you to have it, and we require that you have it in our state. If you're teaching workforce education with drones, you need your Part 107, which is your remote pilot certificate, your remote pilot's license. Not only do you need a license, you need to prepare for the industry role. You're going to need proper PPE. You're going to have to learn how to mission plan, how to do record keeping, which is significant with drones. And you're going to need apps and more apps and more apps and more apps to do the things you need to do in whatever industry you happen to want to fly your drones in. You're going to need flight skills and safety training. These buckets are called NIST buckets. I think NIST is national something, and it's a standards and technology thing. And so we have required certifications. Kids learn they learn how to handle the sticks on a remote better. Sometimes you're doing it without the remote, it's autonomous and flying on its own, but you have to be able to fly those drones without the autonomy there, so that you can handle any situation that comes up. So we do NIST buckets. We fly these and learn how to photograph these and be in the right place at the right time as often as possible. Our kids are going to Skills USA, a career and technical education state competition to fly, and they'll be flying these NIST buckets in North Carolina. And then lastly here, it's not the last thing, but another key thing, you're going to want to have certifications. Right now at our school, we have Scanifly certifications. Again, more coming on that in just a bit. We get drone to map, ArcGIS or Esri drone to map certification. That is 3D modeling and rendering of sites. And we do the NIST buckets, as we already said. Those are all certifications. Not to mention, our kids end up at the community college and either they end up with solar voltaics. They learn how to install and wire solar panels, and so they can get a certification there. Or they end up at Blue Ridge Power, which is one of the largest solar installers in the country, if I'm not mistaken. They're housed in Fayetteville, and they do racking of solar panels, not wiring, siting fields and racking them. So our kids get certifications there, end up in jobs with Blue Ridge Power and that sort of thing. All right. Oh, and I forgot, if you're doing workforce education, you're going to need drones. We start with, it's part of a whole program with energy, but there are 3 courses now in drones. Part of that is because our state requires 3 courses for the drones. We start with a fundamentals class, which we use the Tello drone in. It's a good sturdy thing. We have used our other drones with our advanced class to go find drones that are on roofs. We have pulled drones, little tiny drones, mind you, out of fences. Propellers have flown off because they don't get put on properly. Their fundamentals course, you need a sturdy little drone that doesn't cost a lot of money because it's going to get beaten up. And we are constantly ordering new or trying to print, which is getting more successful all the time, 3D print parts to repair these things, but they hold up really, really well. So you're going to need some of these. We have 15 in our program. This is my favorite little drone. It is the Mavic Mini Pro 3, and we like this. we like I don't know if you can see that arrow on your screens or not, but we like the screen that comes with it. Our students were at a school that has its challenges financially. They're deeply underserved, and they may have phones, but they don't always have connections except when they come to school. Well, having a screen that is that can connect automatically is wonderful, because we don't have to rely on their phones and their service or their batteries. It's just here. Now, that's not every drone, right? Like it's getting to be more and more drones, but it's certainly not every one. This is a mid-range cost drone. And again, it's pretty sturdy. So they've had fundamentals, and they've learned to fly the small drone. Now, when they get to our drone 1 course, our second course, they're learning about the test. And we do provide some flight time as soon as they take and pass the Part 107 test. So this is the first drone they fly, has a great camera. It's GPS, so it doesn't, the Tello drone relies on sensors to hover. This relies on multiple satellite connections and GPS. So it's a wonderful drone to train with. It's all you really need. If you're just training, you can take all the pictures you need. But if you're an energy industry person, and you're wanting to fly drones in the energy industry, you're probably going to need at least one of the more expensive drones. This is the Mavic 2 Enterprise. It comes with the FLIR thermal camera, which you can't hardly do without if you're in the energy industry, or at least if you're flying power lines or solar farms, those sorts of things. Excuse me. So we have one of these, and we don't fly it as much as I think we'd like to, but it's also a very expensive drone, and I want lots of hours on this one before we get to this one. Before we get to the Mavic, which is in the upper right, if you're not seeing my arrow. The lower left is the Autel Evo. This is a workhorse of a drone. It has the mapping capabilities built into it. We like that. We don't have to connect to a million apps. And right now there's some debate as to whether the DJI drones, which are 80% of the industry, by the way, whether one, they'll be allowed in schools, and two, whether they're going to allow third-party apps. So you need to connect to apps in order to map, do an autonomous map, perhaps, right? Well, this has it already built in, and you don't have to worry about it. It also has the orbit that we need to do Scanifly's rooftops. So we like this drone. We just have one right now. Again, it's a more expensive drone. It does a lot. I think it's a 5K camera or something like that. It's just outstanding. In the lower right corner, this is not a drone we have. This is here because it's a simulator we have. Flight simulators are absolutely imperative if you're going to start a workforce program with drones in the energy industry. There are some, if you want to spend the money, I haven't convinced my county yet that it's worth the money, but there are some that actually have scenarios with energy implements in them, like transmission towers and things, so you can practice flying around them with the simulator. We have just real flight, which just allows us to fly on rainy days and allows us to fly and get practice before we get onto a real drone, or in between times, right? So we use real flight. That too will be in documents that I'll have for you to use if you decide you might be interested in a program like this. So let's move on. Let's move on to some fun things. This is fun, but it's also incredibly useful. If you look at the lower left, you look at the left side picture. This is a tiny drone we just received. It was sort of donated to us. We have 5 of them. It's the size of it sits in the palm of my hand. It is teeny tiny, but students build it. They put in the motors. They connect the wires to the different interfaces inside. They learn about those interfaces. In the background, you see what looks like a little canister. Those are actually goggles, and you can do this first-person view. So they learn about the pieces and parts of a drone, which is typically a part of curriculums anyway. So they build it and they learn it better by doing it. And then they can fly this little thing. It flies really quite fast, and they do it with first-person view. This would be the first time in our courses that a student gets to do something first-person view. We don't spend a lot of time with it. First-person view cannot take the place of your visual line of sight of your drone. So you always have to have a visual observer with you regardless. But these are coming. They're being used a lot more in terms of first person view for all sorts of things. So we want them to have the opportunity, and we like that they learn how to build the drone besides, at least the small one. And then this is totally for fun on the right-hand side. This is actually my personal drone. I bring it in. I let my Drone 2 students, which is an applications of drones. It's once you have your test, I let my Drone 2 students fly my drone. This is the handle down there, the little gray piece is the remote control. Right. And then you have its first person view goggles and a fancy, fun little drone to fly. So that's just for fun. Again, engagement gets kids wanting to learn and have more work with drones, and all of our time is around energy. So, all right. So things that we specifically do with the energy industry. We can't do all of those things we saw at the beginning, but there are some things we can do. We've combined with our local utility, which is something I strongly suggest everyone does if they want to employ drones in the energy industry. And we will fly power lines. Our utility does not have a drone pilot on board. Every once in a while, they'll contract for drone pilots, but they will allow us, they'll either send someone out with us, or we'll get a drone professional to go out with us, and we are flying a power line. Not much so far, but this picture on the right is a picture that students took of equipment. There is no way on the planet that our school board would allow us to get in a cherry picker, go to the top of a pole, and look at it for the sake of learning about equipment on a pole. But we can fly a drone up there in a heartbeat, be nowhere near that equipment, still get a good view of it, and then start learning what is an arrestor and what is an insulator and where's the primary line and that sort of thing. Kids, I mean, they like it. I can hand out this sheet of paper in the middle. I do. But we go to school and we fly a pole, or we go out with an energy expert and we fly there. We also will fly, the picture on the left, we will fly with our thermal camera. And the plans were, I'd hope to have this done before today, that we would fly already with the professionals with our thermal camera and present to them what we see. They help us know what is and isn't, a problem, so that we learn it as we go. That hasn't happened yet, but we're trying, and we hope to be out there before the end of the year, flying with our thermal camera and looking to see what we see. We think that we will impress folks with what we see and what we know so much at our utility that they might just start looking at more drone use in the energy industry. And if you look at the sentence up here up top, consider the typical lineman crew can inspect 1 to 2 poles per day. That information, by the way, came from a lineman who now flies drones for an energy company. He says a typical drone can inspect 10 to 20 per day, and drones can identify up to 30 to 70% more defects than just a person getting up there. That's partly because what typically happens is you not only have a person on a cherry picker looking at a distribution line, but imagine transmission lines. You might have someone up there and you have a helicopter going. The more difficult it is to inspect a pole, then the more likely they are to miss defects, but not a drone. So you can spend $10,000 an hour hiring, I think it's $10,000 an hour, maybe it's $10,000 a day. I think that's what it was, hiring a helicopter to fly. Or you can spend $40,000 on a fully equipped drone and use it for years, right? And you won't ever need a helicopter again, probably. I mean, you might, but a lot less. So it's financially important to the energy industry. That's why drones are getting bigger and bigger in their industry, and why we're teaching it. All right, this is one of the best things we've done, and Create Energy is the reason we're doing it. They had Scanifly at a workshop that I was at, showing how we use drones. And we do solar. That's the ultimate end to our program. And here's Scanifly flying drones around rooftops and sighting solar on rooftops without ever having to go up on a roof until it's time to put those on. It just seemed like a perfect match. So I started discussions with Scanifly in my county, and we all came to an agreement, so to speak. We have a collaboration, and now my students, my high school students, are taking Scanifly's 3 certification courses in the classroom. We just started last week. It should take us about 3 to 4 weeks to finish all 4 courses. I mean, all 3 courses. This right here on the left, it's hard to get a good picture of a student with the drone, right? But he's looking up at the drone. We are practicing what they call a context flight. And we had to go next door to our softball field. We have 2 mini trees in our field, but we went to the softball field. It's a 4 complex softball field, and we flew a context flight. That's about 100 to 125 foot above that building at a 30 to 45 degree angle. They have to choose how far out they are. And they just use their drones to fly an orbit, an automated orbit around the building, taking pictures every so many feet. We don't have the ability, we found out, with our Mavic Mini 3. We can only do video, or we have to manually take the pictures. It can be done manually. I just spoke with Scanifly yesterday, checking that out. So they practice flying a context flight, and then they would go down to a lower level, and they would do a detail flight to get more data on the roof. And then we take that back in the picture on the right at the computer. You know, they're learning how to use this program. They don't know how to use it yet, but the information they collect goes into the computer program, and it can help them then site solar on a roof, look at shade, like shade plans and things like that. Like, what happens if the tree is over here in this picture, and how much shade is it going to be during the entire year? The program allows them, excuse me, to look at that. The bottom picture in the middle is just an example of a Scanifly home with solar sited on it, and a drone that did it. Excuse me. All right. How am I doing on time? Doing okay, I hope.
We are a little bit over, and we have a handful of questions in the chat. So I don't know how much you have left in your presentation. I just want to make sure we get a couple of minutes in there so we can answer some of the questions we have in chat.
Okay, well, what I'll do is I'll sum it up. We also are looking to do site assessments for solar fields. This young man in the bottom picture, he is a graduate that's working at Blue Ridge Power now. They wish they had 10 of them, he said. Excuse me. He's going to be flying drones for them, doing site assessments before, during, and after as they rack solar panels. So that's that. And these are just logistics that I think anyone probably can get later, but the cost of engagement and what you need if you're just going to engage kids in your classroom, like with a lesson or workshop, and then workforce education. Here are the different things that people might need to consider for that. Next steps, that'll be on the final thing that I have in my contact information. So that would be it.
Okay, I'll give you a couple of the questions, and then so the first is from Ed Franklin, and he says, what vendor did you use for your Mavic 2E drone system?
Okay, so that will also be in the paperwork that I have, but I use Paul Rossi 910 drones. He's originally from Fayetteville. He's a former helicopter mechanic, actually, but now he has a huge business with drones. He's flown for Causey Aviation. He's delivered for Walmart. He's been the delivery guy, delivering groceries from Walmart to neighborhoods. I mean, he's done everything, and he's directly on we have a board of directors for our academy. He is on my board of directors. He's just an amazing guy. He will help you, educate you if you need it. He'll just give you all you need. So I'll make sure that 910 drones, he's out of Holly Springs now, in North Carolina, but I'll pass his name along.
Okay. And then Lindsay had asked, where would we get a flight simulator? I'm assuming that was in the drone slide that you talked about.
Sure. So the real flight simulator, you can go online and you can get it at Amazon, right? You might, though, if you're in schools, you might check with your county to make sure what they will agree to or not. Originally, when we had real flight, the county kind of came through and took our computers, and off went our licenses at that point in time. And then they wouldn't approve real flight. But somehow or another, somebody worked a miracle somewhere. We have it back, right? So it's just maybe $170 for a simulator, right? So you just go on and get anywhere. It is an all flight simulator too. You can do airplanes with it. They just have a drone section that we use. But it's really inexpensive. Now you do need to buy, probably will need to buy the remote control with it. So the price is going to go up a little bit from 179, but the simulator itself is about $179. I think that's right.
And then Lindsay also asked about the Scanifly classes, and I even know, Lindsay, and I can tell you Joel has a little bit of experience with these too, but it says, would the 3 Scanifly classes be appropriate for a community college workforce development program? Do students obtain their 107 at the end?
Okay, so they have to obtain their 107 at the beginning, actually, and yes, it's probably more relevant to community college than it is to high school, because there just aren't that many high school programs out there. But the very first associate surveyor, which my kids just finished this week, it's 4 hours. It goes over part 107, the rules and things, but you're going to have to spend more time going over that, I think, than just what you get in a few hours. Right. But they also say that with Scanifly, they're like, okay, you need to study this, and they give you some links and things to go to. And then they discuss how to use the cameras. They teach you about aperture and shutter speed and ISOs and all of that sort of thing, so you can deal with it in a later course that they offer. But I would wholeheartedly suggest that, community college get with Scanifly if this is something that they do with solar. I think it's a fabulous program. I'm excited to be a part of it. I talk with Daniel probably 2-3 times a week. So
He is pretty wonderful. We've done a good amount of work with Scanifly.
yeah,
They're pretty fantastic.
they are. And I mean, I think their product is just fabulous. I mean, we're just now learning about it, but I don't know. My kids so far have done pretty well.
Okay, and Kathy Alfano asked, do you need to get permission to fly drones around your town?
Okay, boy, that's a complicated question, right? So, maybe. First, you have to have a license to fly, right? Unless that drone weighs less than a half a pound, you must have a license to fly it. You should either get the trust license, or if you intend to fly commercially or even education, it counts as education. You can't just use a trust license if you're using the bigger drones. You have to get your Part 107. But when you do that, you're going to learn about airspace. So my school happens to be in what's called Class C airspace, at the outer limits of it. I can be on one half my tennis court, and I have zero ability to fly. I cannot get anywhere off the ground if I'm on that spot. If I step across the net, it just so happens it's where a grid line runs through, and I can fly to 100 feet. So yes, you have to have permission to fly. You have to know your airspace to be able to fly in it. If you're just flying telos, you're good to go. But if you're flying any other drone, then you're going to have to know your airspace. You're going to have to get your Part 107 and if you're doing it for education.
Okay. There has been a request for a copy of your PowerPoint slides, and if you'd be willing to share those with me, I can make sure the participants get those. Would that be all right, Denise?
That will be fine. I'm in Canvas, so I'm going to have to
Yeah.
download it as a PowerPoint and then check it out.
Yeah, and you can share them with me, and I will make sure the participants get those. Ed asked, do you have a subscription for the drone blocks?
Right now it's free. So you can, I'll send that link so that you can have the link, but right now it's free. There's been some difficulty with Chrome, but I think they fixed that. Or maybe it's iOS and it's on Chrome. But it's been fixed. We use it constantly. We take computers with us everywhere we go with drone blocks on it. We had a little trouble last summer, but that was partly due to what's going on with drone blocks.
Okay.
And I can also provide some other curriculum that's just amazing to use outside of Drone Blocks. Drone Blocks lets you code, right? That so you can code code the drones. But boy, there's some amazing things you can just do flying, and there's some amazing curriculums out there that you can use. And the one off the top of my head is called Drone Legends. It's just fun with kids. I mean, just I can't say enough about Drone Legends. It's just a wonderful little curriculum.
And Ed says they use Real Flight 9.5. He says the challenge is the firewall for institution computers.
Yep. And we had the same problem, but our technology okayed the purchase of our most recent. I think we have 10. We just got it. Like it literally just came into my room last week. It's not up and running, but technology has to approve everything we purchase, and they've approved, and we're going to deal with whatever firewalls. But yeah, that's true.
And we are way over on time now, so I'm just going to say this is the one last thing from Ed, and he says, "Are you using a mapping application?" And we are going to close it out with that. So
yeah, our state, we have drone courses that are offered through CTE, and they make arrangements with companies. We have arrangement with Drone Deploy for mapping, but then we also use, because it's free for most schools, ArcGIS, Esri Drone to Map. You just have to ask them for the Drone to Map application.
All right. Well, thank you so much, Denise. This has been really informative, and I think everyone online really got quite a bit out of it. If you want to send those resources to me, I can make sure that everyone that was online today gets those.
Okay.
I will get this recording up on the Create website sometime next week, and I will get an email out to the Create audience. So for those of you that were online today, you can go back and you can review the recording sometime after next week. So we appreciate you all joining us today. And if you are interested in any of the upcoming webinars, feel free to reach out and email me once you receive notification of those, and we would be happy to see you online in the future. Have a great weekend, everyone.
Thank you.
Thank you.
Thanks, Denise.
Thanks.
Thanks so much, Denise. That was great.
You're welcome.
Learned a lot. Thank you.
Thank you, Denise. Really appreciate your time.